Alright, we're going to talk about trapezoids today. A trapezoid is a quadrilateral with exactly one pair of parallel sides. So, it's a four-sided polygon, and it's got one pair of parallel sides. We've been talking a lot lately about parallelograms and different types of parallelograms, rectangles, rhombi, squares, and all of those, all parallelograms, both pair of opposite sides are parallel, so you end up with two pair of parallel sides. Trapezoids only have one pair of parallel sides. So here's an example of a trapezoid. Notice that the arrows here and here tell you that these sides are parallel. That's one pair of parallel sides. Notice the other pair of opposite sides are not parallel. So this is a trapezoid, one pair of parallel sides. Alright, different parts of the trapezoid. The bases are the sides that are parallel to each other. So this would be a base, and this would be a base. We're going to do some formulas later, and we'll refer to base 1 or base 2. It really doesn't matter which one is 1 and which one is 2, but you got two different bases. So just to distinguish between the two, we'll call one of them base 1 and the other one base 2. The legs are the non-parallel opposite sides. So these sides are opposite each other, but they're not parallel to each other. Those are the legs. So this is a leg, and this is a leg. And then base angles are angles at the bases. So this was one base. So the two angles that are connected to this base, that's a pair of base angles. And then you actually have another pair of base angles that's not shown in the picture here, but you have another base, and so the two angles that would be connected to that base, that's another pair of base angles. So you got two pairs of base angles because you have two bases. Alright, so those are the parts of a trapezoid. Now we have one particular type of trapezoid we're going to talk about called an isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So it's not marked on here, but these are parallel. Those are the bases. These would be the legs. So if it's an isosceles trapezoid, we would know that those legs are congruent to each other. Line segment AD and line segment BC are congruent to make it an isosceles trapezoid. Alright, there are some things that we know specifically about isosceles trapezoids. Now these things are not true about all trapezoids. They only apply to isosceles trapezoids. Okay, in an isosceles trapezoid, the base angles are congruent. The base angles of an isosceles trapezoid are congruent. So for example, here's one of the bases. So here is a pair of base angles that are going to be congruent to each other. So angle DAB is congruent to angle CBA. That's one pair of base angles that's congruent. And then along the other base, at either end of this base, you have another pair of base angles. And base angles are congruent. So I know that these two angles are congruent to each other. So I can say angle ADC is congruent to angle BCD. So both pair of those angles are congruent because those are base angles. Another thing that's true for isosceles trapezoids is that the opposite angles are supplementary. The opposite angles of an isosceles trapezoid are supplementary. So this angle and this angle would add up to 180 degrees because they're opposite angles. And this angle are opposite angles. They would also add up to 180 degrees. So I'm going to go ahead and write those statements out. So the measure of angle ADC plus the measure of angle ABC equals 180 degrees. Because they're opposite angles, they're supplementary, which means they add up to 180. So those two angles are supplementary. Now I can also write the statement about these two being supplementary because they're also opposite angles. So the measure of angle BCD plus the measure of angle DAB is equal to 180 degrees. Something else we know about isosceles trapezoid is that the diagonals are congruent. The diagonals of an isosceles trapezoid are congruent. So the diagonals here are line segment DB and line segment AC. Those are going to be congruent to each other. So those are three things that we know about all isosceles trapezoids. Not all trapezoids, just isosceles trapezoids. Alright, let's see if we can take all this information and start solving some problems, answering some questions. So ABCD is an isosceles trapezoid. Decide whether each statement is true or false. So the first statement says the distance from A to C is equal to the distance from B to D. So what part of the trapezoid is that? Those are the diagonals. Line segment AC and line segment DB are diagonals. And trying to say that they're equal or congruent to each other, we just finished learning that that is true for all isosceles trapezoids, and it told us that this is an isosceles trapezoid. So is this true? Yes, this is true. The next statement is that line segment AD is congruent to line segment BC. These are the legs of the figure. They're the sides that are opposite each other but not parallel. Well, by definition, an isosceles trapezoid is a trapezoid with congruent legs. So I know that these legs are going to be congruent because that's true for every isosceles trapezoid. The legs are congruent. So this is a true statement. And the last one says that line segment CA and line segment BD bisect each other. Now, in parallelograms, we learned that the diagonals bisect each other. But that is not something that we learned about trapezoids. It's not true. And while I don't want you to ever just look at a picture and make assumptions, we always go off the information. But if you just look at the picture here, you can probably see that this is not as long as this. That diagonal is not being bisected. It's not being split right through the middle into two congruent halves. This is a false statement. The diagonals do not bisect each other in trapezoids. Alright, let's look at example 2. DONE is an isosceles trapezoid. The measure of angle EDO is 110 degrees. And the measure of angle DEN is 15x minus 5. Find the value of x. So I need to compare these. Remember, in an isosceles trapezoid, we learned base angles are congruent and opposite angles are supplementary. Now, technically, these two angles don't fit either description. But think about this. These angles are base angles. So if that's 110, this is 110. Right? And then these angles are opposite each other. And opposite angles in an isosceles trapezoid are supplementary. So I know that if I add those two together, it'll equal 180 degrees. So we got our equation set up based on what we know about isosceles trapezoids, and from here we just got to solve. So we combine like terms here. Negative 5 plus 110 is 105. We want to get x by itself, got to get rid of that 105. It was being added, so I'll do the opposite and subtract it. And then it's being multiplied by 15, so if I want to get rid of that 15, I do the opposite and I divide by 15. Alright, let's look at example 3. TRAP is an isosceles trapezoid. The distance from P to R is 3x minus 7. And the distance from T to A is 20. Notice that they gave me either a number or an expression for both of the diagonals. And we learned in an isosceles trapezoid the diagonals are congruent. So when things are congruent, that means they have equal measures. We know to set them equal to each other. So I set them equal to each other, solve for x. Want to get x all by itself, got to get rid of that 7. It was being subtracted, do the opposite and add it. X is being multiplied by 3. Do the opposite, divide by 3. And get X is 9. Alright, let's talk about a mid-segment. A mid-segment is a segment that joins the midpoints of the legs of a trapezoid. It is parallel to the bases. Alright, so this right here would be the mid-segment as long as these segments are congruent and these segments are congruent, because it has to go from the midpoint of this leg, so I need to know it's right in the middle, bisecting that side, and it goes from that midpoint to the midpoint of the other leg. So again, I need to know it's right in the middle, bisecting this leg. So I need to know that those are congruent, or I need somebody to tell me that these are the midpoints of the legs. So this right here is the mid-segment, because it's going from the midpoint of line segment PT, the midpoint of line segment PT, to the midpoint of line segment RA. Midpoint of line segment RA. So the mid segment goes from midpoint of one leg to the midpoint of the other leg. And then remember, the parallel sides are the bases. So here's base 1 and here's base 2. Now we have a formula that we can use for the length of the mid segment. The mid segment is equal to base 1 plus base 2 divided by 2. Essentially, it's the average of the two bases. Well, if I take these two bases, take their lengths, and add them together and divide by 2, I'll get the length of the mid segment. Alright, so let's take that information and let's try example 4 down here. In trapezoid ABCD, line segment EF is a mid-segment. Find each of the following. Alright, now as soon as I read that, I want to put as much information in the picture and that visual as I can get so I don't forget it. If I know that this is a mid-segment, they told me it is, then it has to go from the midpoint of one leg to the midpoint of another leg. So as soon as I read that, I'm going to mark these congruent, and I'm going to mark these congruent, because I know that E is the midpoint of this side and F is the midpoint of that side. That's the only way line segment EF can be a mid-segment. And they told me line segment EF is a mid-segment. And if these are the legs, then that means these have to be the bases. They told us it's a trapezoid, and in a trapezoid the bases have to be parallel. So there's the information I already know without anything else yet. Now I want to use pencil to label because we got different problems using the same picture, so I want to be able to erase after I've done one problem. So this tells me the distance from A to B is 25. The distance from D to C is 13. And I want to find the length of line segment EF, the distance from E to F. So I'm finding the mid segment. So I'm going to take my formula that we talked about earlier. Base 1 plus base 2 divided by 2. So let's do that. Base 1 plus base 2 divided by 2. And that should give me the mid segment. So 13 plus 25 is 38. And 38 divided by 2 is 19. So I know the distance from E to F would be 19. Okay, I'm going to erase that from the picture so I can label it with the new problem. Let's try another one. It says the distance from A to E is 11. The distance from F to B is 8. And we want to know what is the distance from A to D and what is the distance from B to C. Now remember, because line segment EF was a mid-segment, I knew that this was the midpoint of this side, making these two segments congruent. F was the midpoint of this side, making these two segments congruent. So if this is 11, this is 11. And then what does that make the distance from A to D? 11 plus 11 is 22. On the other side, these are congruent. So if this is 8, this is 8. And then the distance from B to C, 8 plus 8 is 16. Alright, let's erase that up from the picture. Let's try another one. Alright, so for C, it says the distance from A to B is 29. The distance from E to F is 24. And we want to know what is the distance from D to C. Now, this one is a little more challenging than what we've already done so far. We're still going to use our formula up here, but it's no longer the mid-segment that we're looking for. It's one of the bases. So let's see what this looks like when we set up the formula. So the distance, let's see, the mid-segment, 24, equals base 1, which we don't know yet, so I'm using a variable, plus base 2, which is 29, over 2. So there's our equation. The mid-segment equals base 1 plus base 2 divided by 2. And I want to solve for x. X is representing the distance from D to C. Okay, well, there's a couple different ways I could go about doing this, but first thing, I don't want this fraction going on over here. I need to get rid of that denominator. So since all of this is being divided by 2, I can get rid of that 2 by doing the opposite operation and multiplying by 2. Now if I do that on one side, I got to do it on the other side. So when I multiply by 2, 2 times 24 is 48. On the other side, I multiply by 2 just to get rid of that 2. So what I have left now is x plus 29. So then I need to get x all by itself, so I subtract the 29. And that gets rid of that. And 48 minus 29 is 19. So the distance from D to C is 19. Alright, one more of these problems. Alright, the distance from A to B is 7y plus 6. The distance from E to F is 5y minus 3. And the distance from D to C is y minus 2. And we want to solve for y. It's the same formula, we just got a little bit more complicated now. I am going to show the work over here where I got a little bit more space. So I'm just filling out this same formula, same one right here. Start with the mid-segment, 5y minus 3, equals base 1, y minus 2, plus base 2, 7y plus 6, divided by 2. So there's our equation, and we just have to solve this equation. Same first step that I did over here. I don't want that 2 in the denominator. I want to get rid of it. So the first thing I'm going to do, all this is being divided by 2. I can do the opposite, multiply by 2 to get rid of that. Now if I multiply by 2 on one side, I got to multiply by 2 on the other side. Now if I multiply this side by 2, I'm going to put parentheses around it, put the 2 out in front, because all of it needs to be multiplied by 2. I have to distribute that multiplication. So 2 times 5y is 10y, and 2 times negative 3 is a negative 6. Over here, all I did was get rid of that 2 in the denominator, so everything else stayed the same. Okay, so I got rid of the problem of having a denominator. Now I can combine like terms on the right side of the equation. Left side of the equation is already simplified. So over here I got a y, and then 7 more y's, that's 8 y's. Constants, we got a negative 2 plus 6 is 4. Now I don't want y on both sides of the equation, so I got to get rid of one of them. I'm going to subtract 8y and get rid of it on this side. 10y minus 8y is 2y. I got rid of that. The only thing left on that side is 4. Now I can work on getting y all by itself. I'm going to move this constant first. It's being subtracted, so we'll do the opposite and add it. And then y is being multiplied by 2, so I divide by 2. And 10 divided by 2 is 5. So y is equal to 5. Alright, let's do another one. Find the value of x for the trapezoid. You should notice these segments marked congruent and these segments marked congruent. So while they never said the word mid-segment, I know that this piece right here that's labeled with X is a mid-segment because it is going from the midpoint of this side to the midpoint of this side. So it is a mid-segment. Okay? So remember, the mid-segment is equal to base 1 plus base 2 divided by 2. So 24 plus 34 is 58, and 58 divided by 2 is 29. So x is equal to 29. Alright, one more. Find the value of x for the trapezoid. So again, same formula. Again, I know this is a mid-segment because these are marked congruent, so this is the midpoint of that side. These are marked congruent, so this is the midpoint of that side. So it's going from midpoint of one leg to midpoint of another leg. That's a mid-segment. Mid-segment equals base 1 plus base 2 divided by 2. Now typically when I've set up this formula, I like to get rid of that 2, but that's when there's a bunch of variables. That's all numbers on this side. So 12 plus 30 is 42, and 42 divided by 2 is 21. So then we just finished getting x all by itself. I subtract 3 and then divide by 2. Alright guys, let's summarize what we've learned today. There's some things we learned that are true about all trapezoids, and some things that we learned are true specifically on isosceles trapezoids. So a couple things we learned about trapezoids. One can be found in the definition. Trapezoids have one pair of parallel sides, and that one pair of parallel sides are called the bases. The other thing that works for all trapezoids that you might not think to write down is that whole thing with the mid-segment. The mid-segment is equal to base 1 plus base 2 divided by 2. And that works for all trapezoids, not just isosceles trapezoids. That mid-segment formula works for all trapezoids. Then the other things we learned today only apply to isosceles trapezoids. Now by definition, with an isosceles trapezoid, the legs are congruent. And then there was 3 other things that we learned about isosceles trapezoids. The base angles are congruent. The opposite angles are supplementary. And the diagonals are congruent. So those are the things that we learned about trapezoids, and those are the things we learned about isosceles trapezoids.